All right, guys, welcome into Private Pilot Lesson 2.3, talking about a very important instrument. That instrument is the altimeter. The altimeter works, again, as it's a part of that pedostatic system. Before we learn more about the system itself, let's talk about the instrument and learn how to read that instrument. Again, I couldn't pick a better graphic. This is the actual FAA written test graphic, so you get to see that sort of stuff. Now, the problem I have with this graphic is the three altitudes they give you, because I didn't achieve any of these three altitudes you're looking at probably until I was working on my commercial pilot certificate. So FAA, I appreciate you updating the written test. I don't appreciate you putting these crazy altimeter graphics up there, because let's look at graphic number 1. What altitude is that showing us? Well, if you jumped any conclusions, you said 500 feet. Well, 500 feet, unfortunately, is incorrect. The correct altitude is 10,500 feet. Why is that? Well, there's that long hand that's pointing straight at the 5. You're right. That is the hundreds hand. So there is a 500 feet in there. Then there's that short, fat hand that's in between the 0 and the 1. That's our thousands hand. You say, well, it's not quite to the 1 just yet. But look at the skinny short hand to the right of it. That is our 10,000s hand. And that 10,000s hand is pointing right at the 1, meaning 10,000. 10,500 feet is what the altimeter 1 is showing us. Again, 10,500 feet, I probably wasn't even a commercial pilot until I even climbed to an altitude like that. But we're being quizzed on it here. How about altimeter number 2? Altimeter number 2 now that you're looking is showing us 14,500 feet. How do I know that? Well, my hundreds hand, the long skinny one, is pointing right at the 5. My thousands hand, the short fat one, is in between the 4 and the 5. And then show me somewhere in the 4s, 4,000, 14,000, we don't know. And then my 10,000 hand, the skinny one, skinny short one, is in between the 1 and the 2, showing me I'm somewhere in between 10,000 and 20,000. So 14,500 feet. How about, and it's not a very easy one, it's kind of a trick question, altimeter number 3. Altimeter number 3 says what? Altimeter number 3 is showing you 9,500 feet. How do we know that? Well, again, it's a trick question because the 10,000s, the short skinny one, appears to be on the 1, but it's not quite, because the hundreds hand is still on the 5. 500 more feet, and then it'll officially be on that 1, showing us at 10,000. Not quite, we're at 9,500 feet. I know those aren't easy ones to look at, because most you're flying, especially if you're flying in Florida at sea level where I'm at, we're at 2,000, 3,000, 4,000 feet. Maybe if you're flying out west, your altimeter shows this sort of stuff, but certainly if you're not flying anywhere near sea level. But we need to know it for our FAA written test, and it's important to know it for the future as you begin to fly higher and faster aircraft throughout your training. Now, there's something else I want to share with you about the altimeter before we dive into how it works. It's something called the Kollsman window. The Kollsman window is how we set the altimeter setting on our actual altimeter. You see, our altimeters aren't just set to 0 at the ground and we go fly, because there's a difference between what's called MSL, our height above mean sea level, and our height AGL, above ground level, because terrain is always changing. Our height AGL, above ground level, is always changing. And so is our flight MSL, above mean sea level. We set our altimeter setting to be adjusted for sea level. That's why flying out west, your altimeter might already say 2,000, 3,000, 4,000 feet, simply just sitting on the ground. I've been to the Leadville Lake County Airport in Colorado, the highest airport in North America. 9,934 feet is the field elevation there. It was a little weird sitting on the ground and having my altimeter read almost 10,000 feet when I'm on the ground. That's why we set our altimeter to mean sea level, and we do that using the pressure in the Kollsman window. It's a simple just turn and twist to the local altimeter setting. You do that via that Kollsman window there. Now let's take a second and share a little bit about how this actually works. our altimeter is on our pitot-static system. Now I have an actual altimeter here that you can see, very similar to that one. We've got our hundreds hand like we talked about. We've got our thousands hand, and they have a little bit of a different 10,000s hand. You can see here, there's a skinny, but it's a little bit longer there. You can see how that works. It's cool to see the back side of this as well and how it works. Pressure literally comes into this casing, and these are what's called aneroid wafers. These aneroid wafers, inside of them, are set for standard pressure. Think of it like a balloon. If you released a balloon from right here with helium straight on up, would that balloon continue to outer space? Well, the answer is no. It would eventually pop. Why would it pop? Because of the pressure. This is what happens with our aneroid wafers. Our aneroid wafers expand and contract, moving this little arm here, which then gives us an adjustment in our actual altimeter setting, as you can see there, and that's how we move our needles. These aneroid wafers expand and contract. The altimeter is a pressure-sensitive instrument, and aneroid wafers are your buzzword. They're very advanced stuff, but certainly something good to know. Now, let's take a look inside the pitot-static system to really see how it all comes together and learn about some possible pitot-static system errors. So here we have a great sim from our friend Louise, and there's a link down underneath this if this is a sim you want to play with and kind of learn a little bit more about. What we're looking at is we have our simulated pitot-static system here. Here's our airspeed indicator, vertical speed indicator, and our altimeter, which is what we're talking about. Here's the simulated system. Here's the reference system with what should be happening. So what I'm going to do is follow my cursor. I'm going to drag us. We're going to just climb real high here at about 70 knots. And you're going to see our altimeter start to work. Our airspeed is going to slowly increase. Down here you can see our pitot tube, and over here you can see our static port. Now let's learn something here. I'm going to come down here and I'm going to block my pitot tube. Let's do that. So you can see here I've blocked my pitot tube, again still part of that pitot-static system, and I'm looking, my airspeed is showing 0. Down at the reference system, this is what it should be showing, but here's what it's actually showing with that blockage there. My altimeter still works, my vertical speed indicator still works. Let's unblock that pitot tube, and now let's focus on what we wanted to talk about, our altimeter. Let's block this guy right here, the static port. Let's say a bug flies in there, we block our static port. What happens? Well, by blocking our static port, our airspeed goes to 0. Our altimeter freezes on whatever altitude the blockage occurred. Remember we said it's a pressure-based instrument? We've simply just locked in whatever pressure that is there, and our vertical speed, which we'll talk about in a future lesson, is done the same. However, this is what we should be showing. You see, the pitot-static system all works in unison. This is why pre-flighting that pitot tube, pre-flighting that static port is so important. Again, this simulation, there's a link underneath this video to that simulation so you can check it out and kind of play around with it a little bit yourself and just learn how to read that altimeter. Learn what happens when you block certain things. The drain hole in the pitot tube opening, use the alternate static source. I encourage you to play around with this sim to learn more about your pitot-static system.